Have you ever wondered why, when you stand outside on a quiet, moonless night and stare deeply into the vast empty spaces between the twinkling lights, you feel a subtle, inexplicable thrill mingled with a profound sense of peace? We are so accustomed to thinking of ourselves as the ultimate observers, the active participants standing on the safe shores of the cosmic ocean, casting our gaze outward into the infinite and silent dark. We look at the stars, but we rarely pause to consider the spaces in between them. We are used to density, to things being close together, to the world being full. But step outside our solar system and emptiness becomes the rule. The universe is not merely an empty canvas waiting patiently for our eyes to trace patterns upon it. It is a dynamic, ancient, and profoundly mysterious expanse that holds secrets older than the earth itself. What if, in our relentless and beautiful quest to peer deeper into the absolute void, we found something that challenged our very understanding of observation? The silence of the night sky is deceiving. It is not an empty silence, but a quiet, ancient anticipation. When we look up, we are catching ancient photons that have traveled for millions, sometimes billions of years, crossing the unimaginable gulfs of intergalactic space just to end their gentle journey against the retinas of our curious eyes. This is the quiet journey of light, a testament to the fact that we are the part of the universe that has woken up and started asking questions about itself. If you find peace and wonder in these quiet journeys through the cosmos, I invite you to join our community. I am Theodore, the researcher, and I am here to guide you through these contemplative explorations into the unknown. I have noticed that 71% of the gentle souls who watch these videos and share in this quiet wonder have not yet subscribed to the channel. If these stories bring you comfort and spark your cosmic curiosity, please consider subscribing. It helps us bring more content like this to you, and it lets us know that you want to keep exploring the universe together. Your presence here is valued, and together we can continue to uncover the gentle mysteries hidden in the dark. Now, let us return to our journey into the quiet depths of space. The story of how we observe the distant cosmos is a beautiful testament to human ingenuity and our endless desire to understand our place in the grand design. In the early days of astronomy, telescopes were limited by the size of their lenses and mirrors. Larger telescopes could gather more light and see fainter objects, but there were practical limits to how big you could make a telescope on the ground. The atmosphere also posed a formidable problem, as Earth's atmosphere is constantly moving and shimmering, which is why stars appear to twinkle. This twinkling blurs the images that ground-based telescopes can capture, limiting how clearly they can see distant objects. When the first telescopes were turned toward the heavens in the 17th century, observers began to realize that the milky glow above us resolved into countless individual stars, too faint and too numerous to see with the naked eye, but visible through the magnifying power of glass lenses. This was the first quiet hint that our galaxy was far larger and contained far more stars than anyone had ever imagined. Over the centuries, our tools grew more sophisticated. In 1790, a German-born British astronomer named William Herschel was systematically scanning the night sky with his telescope. He pointed his instrument toward a region of sky in the constellation Virgo and noticed a faint, fuzzy blob of light. At the time, Herschel had no way of knowing what he was actually looking at because the technology did not exist to measure how far away this object was. He simply logged it as another mysterious cloud, like objects scattered across the heavens. It would take over a century for us to realize that this faint smudge was actually an enormous cosmic monster, a galaxy that goes by the somewhat boring name of IC 1101. To truly understand the vastness we are peering into, we must recognize the scale of our own neighborhood. The Milky Way is home to somewhere between 200 billion and 400 billion stars. Our Sun and its family of planets orbit the center of the galaxy at a speed of about 500,000 miles per hour. Even at that tremendous velocity, it takes our solar system about 250 million years to complete a single lap around the galactic center. In the entire time that dinosaurs roamed the Earth, our solar system did not even complete one full orbit. The space between stars in the Milky Way is almost unimaginably empty. Stars are separated by such vast gulfs that the chance of any two of them colliding by accident is essentially zero. Entire galaxies can pass through each other without any stars actually hitting one another. This gentle emptiness is the canvas upon which the universe paints its grandest structures. Today, we estimate that there are around 2 trillion galaxies in the observable universe. 2 trillion, that is a 2 followed by 12 zeros. Each of those galaxies contains billions or even trillions of stars. The numbers become so profoundly large that they stop meaning anything to our fragile human brains. Yet, we continue to look, driven by a deeply rooted need to comprehend the infinite. Everything changed for our cosmic perspective in the late 20th century. For most of that century, astronomers could see that giant galaxies existed, but they could not study their detailed structures due to the blurring effect of our planet's shimmering air. This limitation was overcome with the launch of the Hubble Space Telescope in 1990. Floating serenely above the atmosphere, Hubble could capture images with incredible clarity. In 1995, astronomers did something that seemed almost absurd at the time. They pointed the Hubble Space Telescope at a tiny, seemingly empty patch of sky, about the size of a grain of sand, held at arm's length. They let the telescope gather light from that tiny, dark patch for over 100 hours. What the resulting image revealed was absolutely astounding, changing our perception of the dark forever. That tiny patch of sky contained about 3,000 galaxies, each one an island universe containing billions of stars. The conclusion was inescapable and profoundly humbling. Everywhere we look, no matter how small the area of sky, we find galaxies. But distance in the cosmos is not just a measure of space. It is a measure of time. When we look at a distant galaxy, we are not seeing it as it is today. We are seeing it as it was when the light we detect today first began its journey toward Earth. If we look at a galaxy a billion light years away, we are looking at light that left its home when Earth was still mostly populated by single-celled organisms. Complex animals had not yet evolved, and the dinosaurs would not appear for another several 100 million years. Every major event in human history happened while that ancient light was still quietly crossing the absolute emptiness between galaxies. In a very real sense, we are archaeologists of the cosmos, studying the deep past rather than the present. Every observation of a distant object is a look back in time, a quiet glimpse of how things used to be rather than how they are now. This beautiful time delay allows us to study cosmic history directly, tracing the evolution of cosmic structures over billions of years, and this brings us to a new era of observation, an era defined by our newest and most magnificent eye in the dark, the James Webb Space Telescope. Launched in late 2021, this incredible instrument was designed to peer deeper into the universe than ever before, using infrared light to pierce through dense clouds of cosmic dust and see the faint, stretched light of the earliest galaxies. James Webb does not just see the universe. It feels the faint heat of ancient creation. It was tasked with looking into the deepest, darkest voids, places where even Hubble saw nothing but empty blackness. Astronomers selected a patch of sky so dark, so devoid of known stars or nearby galaxies, that it represented the ultimate blank slate. They were looking for the faintest whispers of the first stars, the primordial light from the dawn of time. But when the data slowly trickled back across the millions of miles to Earth, translating invisible infrared waves into stunning visual images, the scientists noticed something that made them pause. In the heart of that profound darkness, there was an anomaly. It was not a grand spiral galaxy with beautiful curving arms made of stars, gas, and dust. It was not a smooth, featureless, giant elliptical galaxy like IC 1101. It was something else entirely. To appreciate the strangeness of this discovery, we must remember how structured the universe usually is. Galaxies are not distributed randomly through space. They are organized into larger structures. They form groups, like our own local group, which contains about 80 known galaxies. They form massive clusters containing hundreds to thousands of galaxies bound together by gravity. And they form the largest structures of all, superclusters, vast assemblages stretching across hundreds of millions of light years. We expect to find matter clumped together in these cosmic webs, held in a delicate balance by the invisible hand of dark matter. Dark matter is one of the greatest mysteries in modern physics. We cannot see it. It does not emit or absorb light, and it only interacts with normal matter through gravity. In a typical spiral galaxy like our Milky Way, dark matter accounts for about 90% of the total mass. When we look into the dark, we are usually looking at the subtle gravitational influence of this invisible framework. But what James Webb's golden mirrors captured in this specific, empty void did not seem to fit the gentle, slow accumulation of hierarchical structure formation, where the universe builds things from the bottom up over cosmic time. The light from this region was ancient, bearing the unmistakable red shift of a journey that had taken over 13 billion years. The expansion of the universe stretches light as it travels, shifting it toward the red end of the spectrum. The more distant an object is, the more the universe has expanded since its light was emitted, and the greater its red shift. This anomaly was incredibly red-shifted, placing it near the very beginning of everything. But its shape and its emission signature were completely wrong for that era. In the early universe, we expect to see small, irregular collections of stars, nothing like the grand structures we see today. These small galaxies formed first from collapsing clouds of primordial gas, and then merged together to form larger ones over billions of years. But this object, sitting quietly in the distant dark, appeared far too massive, far too organized, and strangely luminous in specific infrared bands. It was as if, in a universe that was still learning how to build simple structures, a fully formed, incredibly dense phenomenon was already waiting. As the scientists carefully analyzed the spectral data, breaking the light down into its component colors to deduce what elements were present, the sense of mystery deepened. The silence of the cosmos suddenly felt very loud. When you look at an ancient object, you expect to see the signatures of hydrogen and helium, the simple elements left over from the first few minutes of cosmic history. You do not expect to see the complex chemical signatures of a structure that has undergone countless generations of stellar birth and death. The anomaly defied the timeline. It was a paradox floating in the void. Was it an incredibly massive black hole that had formed directly from a collapsing cloud of gas skipping the star phase entirely? Or was it something far more exotic. Some physicists even began to quietly wonder if we were looking at the effects of dark energy, that mysterious force that makes up about 68% of the total energy in the universe and acts as a kind of anti-gravity, pushing space apart. We do not know what dark energy is made of, where it comes from, or why it has the strength that it does. Could this anomaly be a physical manifestation of these unknown forces interacting in the early universe? We are a species that thrives on patterns and understanding. We are the atoms of ancient stars that have gained consciousness, looking back at the sky and trying to make sense of our origins. The atoms in our bodies were forged in stars. The carbon that makes up your muscles, the oxygen you breathe, the iron in your blood, all of these elements were created in the nuclear furnaces at the cores of stars that lived and died before our sun was born. We are, quite literally, star stuff contemplating more star stuff. And so, when we encounter something in the deep, dark cosmos that refuses to fit our carefully constructed models, it stirs something deep within our souls. It reminds us that for all our brilliant telescopes and mathematical equations, the universe is still vastly, wonderfully unknown. It reminds us to be humble before the infinite. The anomaly spotted by James Webb is a quiet invitation to expand our minds, to embrace the mystery, and to realize that the dark is never truly empty. It is simply filled with wonders we have not yet learned how to see. The silence of the cosmos is not empty. It is a profound and ancient stillness that invites us to listen closer, to lean into the vastness with a spirit of quiet reverence. Have you ever stood beneath a canopy of stars, feeling the gentle breeze of a quiet night, and realized that every point of light you see is a message sent from the deep past? We are so accustomed to the immediacy of our daily lives, to the rush and noise of our crowded planet, that the absolute calm of the universe feels almost alien to our senses. We are used to density, to things being close together, to the world being full. But step outside our solar system and emptiness becomes the rule. This emptiness is hard to wrap your mind around. When we look out into the void, we are not seeing a static painting on a dark canvas. We are peering into an ocean of time where ancient photons have traveled across the darkness just to reach us. It is a humbling thought, a quiet reminder of our place in the grand design. We are tiny, brief observers in a universe that has been unfolding for billions of years. Yet, in our brief moment of existence, we have built golden mirrors and sent them into the cold vacuum of space, simply because we possess an unquenchable desire to understand. We want to know what hides in the dark. We want to know if the universe is looking back at us. If you find comfort in these quiet journeys through the cosmos, I invite you to join our community. I am Theodore, the researcher, and I am here to guide you through these contemplative explorations into the unknown. I have noticed that 71% of the gentle souls who watch these videos and share in this quiet wonder have not yet subscribed to the channel. If these stories bring you peace and spark your cosmic curiosity, please consider subscribing. It helps us bring more content like this to you, and it lets us know that you want to keep exploring the universe together. Your presence here is valued, and together we can continue to uncover the gentle mysteries hidden in the dark. Now, let us return to the deep, silent void, where the James Webb Space Telescope made its unsettling discovery, a discovery that challenges the very foundation of how we believe the universe grew from infancy into the grand structures we see today. To truly appreciate the mystery of this anomaly, we must first understand how we measure the vast gulfs of space that separate us from the beginning of time. Distance is one of the fundamental quantities in astronomy, but it is also one of the hardest to measure. How do you tell how far away something is when you cannot go there and stretch out a measuring tape? For relatively nearby objects, astronomers use a technique called parallax. As Earth orbits the Sun, our perspective on nearby stars changes slightly. By measuring how much a star appears to shift against the background of more distant stars over the course of a year, astronomers can calculate how far away it is. This works well for stars within a few thousand light years. But for more distant objects, the parallax shift is too tiny to measure, even with our most precise instruments. For more distant objects, astronomers use a cosmic distance ladder, a series of techniques that build on each other. One rung of this ladder involves a special type of star, called a Cepheid variable. These stars pulsate in brightness in a regular pattern, and the period of their pulsation is directly related to their intrinsic luminosity. By measuring how bright a Cepheid appears and how fast it pulsates, astronomers can calculate how far away it is. Cepheids can be seen in galaxies tens of millions of light years away. But for such extreme distances as the edge of the observable universe, astronomers must rely on even brighter standard candles. One of the most important of these is a type of exploding star called a type Ia supernova. These explosions occur when a white dwarf star accumulates too much matter from a companion and detonates in a thermonuclear explosion. Because the conditions for this detonation are similar from one supernova to another, they all reach roughly the same peak brightness. By measuring how bright a type Ia supernova appears, astronomers can estimate how far away its host galaxy is. Another technique involves measuring the redshift of a galaxy's light. As the universe expands, light from distant objects gets stretched to longer wavelengths. This shifts the light toward the red end of the spectrum, hence the name redshift. The more distant an object is, the more the universe has expanded since its light was emitted, and the greater its redshift. When the scientists looked at the light from the anomaly captured by the James Webb Space Telescope, the redshift was staggering. It indicated that the light had been traveling for over 13 billion years. The object was sitting in the cosmic dawn, a time when the universe was barely waking up. This extreme distance creates a profound paradox that strikes at the heart of our cosmological models. We believe we understand how the universe builds its beautiful architecture. Galaxies do not form all at once. They grow over billions of years through a process of accumulation and merger. Small galaxies form first from collapsing clouds of primordial gas. Those small galaxies then merge together to form larger ones. Larger galaxies merge to form even larger ones. And on it goes, with the biggest galaxies growing ever larger by consuming their smaller neighbors. This process is called hierarchical structure formation, and it is one of the fundamental principles of modern cosmology. The universe builds things from the bottom up, starting small and growing large through countless merges over cosmic time. In the early universe, when the first galaxies were forming, most of them were dwarfs. Dwarf galaxies play a crucial role in cosmic evolution. They are the building blocks from which larger galaxies are assembled. These small galaxies then merged with each other over billions of years, building up the larger galaxies we see today. Every large galaxy started as dwarf galaxies that came together long ago. But the anomaly did not look like a chaotic, struggling dwarf galaxy. It looked mature, massive, and impossibly bright. It was a giant existing in an era where only infants should reside. To understand how unnatural this is, consider the long, beautiful, and violent process of galactic mergers that is required to build a massive galaxy. When two galaxies begin to interact, the first thing that happens is a gravitational dance. Even when the galaxies are millions of light years apart, they can feel each other's gravity. This gravity begins to distort their shapes ever so slightly. Stars that were orbiting peacefully begin to feel a pull from an unexpected direction. When two galaxies get close to each other, their gravity begins to profoundly distort their shapes. Stars get pulled out of their normal orbits, and gas and dust get compressed and stretched. If the galaxies are similar in size, they might merge together over hundreds of millions of years, eventually forming a single larger galaxy. Long streams of stars get drawn out from each galaxy, forming what astronomers call tidal tails. These tails can extend for hundreds of thousands of light years into space, ghostly ribbons of stars marking the violence of the interaction. Over the next few 100 million years, they swing back and forth, getting closer with each pass until finally they merge completely. During this process, something remarkable happens. The gas in both galaxies gets compressed by gravitational forces and shock waves. This compression triggers massive bursts of star formation. New stars light up by the billions, burning hot and bright. Eventually, the chaos settles down. The two galaxies become one. This process takes billions of years. It requires vast amounts of time for the universe to stir the cosmic ingredients into a massive, stable structure. So how could a massive, seemingly organized structure exist just a few 100 million years after the Big Bang? Galaxies come in many shapes and sizes. The most common type in the nearby universe are spiral galaxies like our own, with their distinctive pinwheel arms and flat rotating disks. Elliptical galaxies are another major type. Unlike spirals, these galaxies have no particular structure. They range from nearly spherical to highly elongated oval shapes, and they are populated mainly by old red stars. There are also irregular galaxies which have no defined shape at all. The anomaly did not comfortably fit any of these categories. It glowed with an eerie, uniform intensity in the infrared spectrum, suggesting a concentration of mass and energy that defied our equations. It was as if we were walking through a forest of newly sprouted saplings and suddenly stumbled upon a towering, ancient oak tree that had no right to be there. The mystery deepens when we consider the invisible scaffolding of the universe. Most of a galaxy's mass is not in stars at all. It is in something we call dark matter. Dark matter is one of the greatest mysteries in modern physics. We cannot see it. It does not emit light or absorb light. It does not interact with normal matter except through gravity. But we know it exists because galaxies rotate in ways that would be impossible if they only contained the matter we can see. Here is the problem. If you add up all the stars in a galaxy and calculate how much gravitational pull they should have, you get a certain number. Then you measure how far stars are orbiting in the outer parts of the galaxy, which tells you how much gravity is actually present. The two numbers do not match. There is far more gravity than the visible matter can account for. The solution, according to most astronomers, is that galaxies are surrounded by vast halos of dark matter, material that we cannot see, but that makes up most of the galaxy's total mass. In a typical spiral galaxy like the Milky Way, dark matter accounts for about 90% of the total mass. Understanding dark matter is one of the biggest challenges facing physics today. We know it is there because of its gravitational effects, but we do not know what it is made of. The anomaly seemed to possess a gravitational signature that was overwhelmingly powerful, suggesting a dark matter halo that had assembled itself with impossible speed. At the heart of this ancient mystery, there might lie an even greater monster. Every large galaxy has a supermassive black hole at its core. Our own Milky Way has one called Sagittarius A star, which contains about 4 million times the mass of our Sun. The physics of such extreme environments is bizarre and counterintuitive. Time itself would pass differently near the event horizon compared to far away. Someone falling toward the black hole would see the outside universe speed up, while an outside observer would see the falling person slow down and appear to freeze as they approach the horizon. Space and time themselves become so warped that the concept of escaping becomes meaningless. Could the anomaly be the result of a direct collapse black hole, a primordial giant that formed directly from a massive cloud of gas without ever becoming a star? If so, it would mean that the universe was capable of producing monsters of unimaginable power right from its very inception. The story of the anomaly reminds us that the universe operates on time scales that dwarf individual lives, individual civilizations, even individual planets. It challenges us to look deeper, to question our assumptions, and to find peace in the realization that we do not have all the answers. The atoms in your body were forged in stars. The carbon that makes up your muscles, the oxygen you breathe, the iron in your blood, all of these elements were created in the nuclear furnaces, at the cores of stars that lived and died before our sun was born. When those ancient stars exploded as supernovas, they scattered their elemental riches across space. Eventually, some of those atoms found their way into a cloud of gas and dust that collapsed to form our solar system. They became the Earth. And then, after billions of years of evolution, they became you. You are made of star stuff. This is not poetry. It is chemistry. The very same processes that light up the distant stars also created the matter from which you are assembled. There is a direct physical connection between you and those distant fires. In a very real sense, when you contemplate the anomaly in the deep dark, you are star stuff contemplating more star stuff. The universe is looking at itself, trying to understand what it is and how it came to be. We are not separate from the cosmos we study. We are part of it, and our curiosity is the cosmos being curious about itself. This quiet realization brings a sense of profound calm. The dark is not empty, and the mysteries it holds are simply pieces of our own ancient unfolding story. Have you ever paused to consider the quiet rivers of time that flow above our heads every single night? When we step outside and look up at the vast star-filled sky, our senses tell us that we are looking at the present moment. We feel the cool night air on our skin. We hear the gentle rustling of leaves in the wind, and we see the infinite points of light shining down upon us, seemingly fixed in the immediate now. But this perception is a beautiful, deeply comforting illusion. The cosmos does not share our human experience of a synchronized present, because light, the fastest messenger in the universe, takes time to cross the endless gulfs of space. Looking outward is inextricably linked to looking backward. The farther away an object is, the longer its light has been traveling through the absolute silence of the void. We are never truly seeing the universe as it is. We are only ever seeing the universe as it was. This simple, profound truth transforms the night sky from a static canopy into a living, breathing museum of cosmic history. It is a gentle reminder that our everyday reality is just a tiny, localized bubble within a much grander, ancient story. When we gaze into the deep dark, we are not just observers of space. We are time travelers standing on the shores of the present, catching the faint, ancient echoes of the primordial past. If you find peace and wonder in these quiet journeys through the cosmos, I invite you to join our growing community of cosmic explorers. I am Theodore, the researcher, and I am here to serve as your gentle guide through these contemplative explorations into the profound unknown. I have noticed that 71% of the gentle souls who watch these videos and share in this quiet, meditative wonder have not yet subscribed to the channel. If these stories bring you comfort, if they help you find a sense of peace in the vastness, and if they spark your cosmic curiosity, please consider subscribing. It helps us bring more content like this to you, and it lets us know that you want to keep exploring the grand mysteries of the universe together. Your presence here is deeply valued, and together we can continue to uncover the gentle, hidden truths waiting for us in the dark. Now, let us return to our journey, delving deeper into the profound paradox discovered by our most advanced golden eye in the sky. The James Webb Space Telescope, a magnificent marvel of human engineering, born from the collaborative dreams of the National Aeronautics and Space Administration and the European Space Agency, was built specifically to look further back in time than we ever thought possible. It was designed to pierce the thick, dusty veils of the early universe using infrared light. Infrared light has longer wavelengths than the visible light our human eyes can perceive, allowing it to glide smoothly through dense clouds of cosmic dust that would normally block our view. This capability is absolutely crucial because the light from the very first galaxies, emitted billions of years ago as ultraviolet and visible light, has been stretched into the infrared spectrum by the relentless expansion of space itself. By capturing these stretched ancient photons, James Webb allows us to peer into the cosmic dawn, the epoch when the first stars began to ignite and push back the primordial dark. But what it found in that seemingly empty patch of space was not the expected faint glow of infant star clusters struggling to take shape. Instead, it found a mature, massive anomaly that seemed to mock the established timeline of cosmic evolution. The great astronomer Carl Sagan once beautifully observed that the universe is not only stranger than we suppose, but stranger than we can suppose. This profound sentiment perfectly captures the intellectual tension and the sense of awe generated by this unexpected discovery. We spend decades carefully constructing theoretical models of how the cosmos operates, piecing together the puzzle of existence using the best data available to our fragile human minds. We assume that the universe builds things slowly, methodically, from the bottom up. We expect to see small, irregular dwarf galaxies in the early universe, slowly merging over billions of years to form the grand, majestic spirals and massive ellipticals we see in our local cosmic neighborhood. Yet, there, floating in the distant dark, was an object that possessed the mass, the structure, and the organized luminosity of a galaxy that should have taken billions of years to evolve. It was sitting in an era barely a few 100 million years after the Big Bang. It is as if we dug into the deepest, oldest layers of the Earth, layers where only the simplest single-celled fossils should exist, and suddenly uncovered the fully formed skeleton of a modern bird. It is a scientific paradox that invites us not to despair, but to embrace a productive humility. It teaches us that our ignorance is not a failing, but a beautiful motivation to keep learning. To truly appreciate the depth of this mystery, we must step back and contemplate the invisible forces that govern the grand architecture of the universe. Space itself is expanding, and not just expanding, but accelerating in its expansion. For most of the 20th century, astronomers assumed that the expansion of the universe was slowing down. This made intuitive sense to our logical minds. Everything in the universe is pulling on everything else through gravity. You would expect all that gravitational attraction to act like a brake, gradually slowing the expansion that began with the Big Bang. We imagined a universe that was slowly coasting to a halt, gently restrained by the mutual affection of all its matter. We believed that gravity was the supreme architect, pulling gas into stars, stars into galaxies, and galaxies into massive clusters. This slow, methodical pulling is what we thought dictated the pace of cosmic evolution, requiring vast eons of time to construct anything as massive and organized as the anomaly spotted by the James Webb Space Telescope. But the universe, in its infinite wisdom and mystery, had a different story to tell. In 1998, two independent teams of astronomers made a shocking discovery. They were measuring the expansion rate of the universe by observing distant supernovas, using them as standard candles to calculate cosmic distances. These brilliant stellar explosions provided a way to measure the vast gulfs of space with unprecedented accuracy. What they found was completely unexpected. The universe was not slowing down, it was speeding up. Distant galaxies were moving away from us, faster than closer ones, and the rate of expansion was accelerating over time. This discovery was so profound, so utterly contrary to human intuition and established scientific dogma, that it fundamentally altered our relationship with the cosmos. It revealed that gravity, the great cosmic sculptor, was not the only force dictating the fate of the universe. There was something else out there in the cold, quiet void, something powerful enough to push the very fabric of space apart. This acceleration is driven by something scientists call dark energy, a mysterious force that makes up about 68% of the total energy in the universe, but whose nature we do not understand at all. Scientists named this mysterious force dark energy. Though the name tells us very little about what it actually is, we know that dark energy makes up about 68% of all the energy in the universe. We know that it acts as a kind of anti-gravity, pushing space apart rather than pulling it together. We know that its effects become more important over time as the universe expands and ordinary matter becomes more spread out. But we do not know what dark energy is made of, where it comes from, or why it has the strength that it does. It is a phantom energy, a silent presence that permeates every inch of the endless vacuum. It might be a fundamental property of empty space itself, a quiet energy woven into the very fabric of nothingness. Whatever it is, dark energy represents a profound boundary to human knowledge, a vast ocean of ignorance that we are only just beginning to dip our toes into. The existence of dark energy makes the anomaly spotted by the James Webb Space Telescope even more perplexing. If the universe is fundamentally governed by a tension between the pulling force of gravity and the pushing force of dark energy, how did such a massive, cohesive structure manage to assemble itself so quickly in the primordial dawn? In the early universe, matter was denser, and gravity should have had the upper hand, allowing the first stars and small galaxies to coalesce. But the sheer size and maturity of this anomalous object suggest an efficiency of matter accumulation that defies our current physical models. It is as if this cosmic giant somehow bypassed the slow, gentle, billions of years-long process of hierarchical merging. Did it collapse directly from an unimaginably massive cloud of primordial gas, forming a supermassive black hole that immediately began churning out energy and organizing the surrounding matter? Or does the early universe possess hidden mechanisms of rapid growth, secret channels of cosmic construction that we have not yet even begun to conceptualize? The anomaly sits there in the deep dark, a silent testament to processes that operated when the universe was just a newborn, processes that may have shaped the destiny of everything that followed. There is a profound meditative peace to be found in this intellectual tension. We are often taught to fear what we do not understand, to view ignorance as an adversary that must be conquered and vanquished. But in the quiet contemplation of the cosmos, the unknown is not an enemy. It is a gentle invitation. It is the vast, uncharted territory that gives science its beauty and its purpose. Every time a telescope like James Webb peers into the silence and finds something that breaks our models, it is a moment of pure, unadulterated wonder. It means the universe is still capable of surprising us. It means the journey of discovery is far from over. The anomaly is not a failure of our science. It is a majestic expansion of our horizon. It forces us to ask better questions, to look deeper, and to realize that our human perspective, as brilliant and determined as it is, represents only a tiny fraction of the infinite possibilities that exist within the cosmos. As we sit here, safe on our rocky blue planet, trying to decipher the faint ancient light of a mature galaxy trapped in the dawn of time, we must remember our own deep connection to these cosmic events. We are not separate from the mysteries we observe. The very atoms that compose the neurons in your brain, the cells in your heart, and the breath in your lungs were forged in the fiery crucibles of ancient stars. The same forces of gravity, thermodynamics, and quantum mechanics that birthed the anomaly also sculpted the elements that make up your physical being. You are the universe observing itself, a conscious manifestation of ancient stardust trying to comprehend its own origins. When we look at the anomaly, we are looking at a distant, mysterious chapter of our own extended history. It is a reminder that while our individual lives may be brief, our physical lineage traces back to the very beginning of space and time. We are intimately, beautifully entangled with the grandest structures in the dark. This realization brings a gentle stillness to the mind. The universe is not a chaotic, meaningless void. It is a complex, evolving, and deeply interconnected web of matter, energy, time, and mystery. The anomaly discovered by the James Webb Space Telescope is just one note in a vast cosmic symphony that has been playing for billions of years. As we continue to gaze into the deep dark, we must do so not with the arrogance of conquerors, but with the quiet humility of students. We must allow the silence of the cosmos to calm our anxieties and inspire our curiosity. The answers we seek are out there, hidden in the ancient light, waiting for us to develop the eyes to see them and the wisdom to understand them. The journey is infinite, and every new discovery simply reveals another beautiful layer of the endless mystery. Have you ever closed your eyes and tried to imagine the most violent, chaotic forces in existence, only to realize that, from a distance, they might look like a perfectly choreographed, silent ballet? When we think of creation and destruction, our human minds naturally conjure images of loud, explosive, and rapid events. We imagine the shattering of glass, the roar of an ocean storm, or the sudden, deafening impact of a falling object. We are conditioned by our earthly environment to associate immense power with immediate, overwhelming noise. But the cosmos operates on a completely different sensory canvas. In the absolute vacuum of space, there is no air to carry the sound of a dying star or the collision of two massive celestial bodies. The universe conducts its most spectacular and terrifying transformations in utter, profound silence. This gentle stillness is a veil that covers the true, dynamic nature of the dark. When we look up at the night sky, we see a peaceful scattering of light, a calm and quiet tapestry. But if we could compress millions of years into a single, fleeting minute, we would witness a universe that is constantly moving, shifting, and tearing itself apart to build something new. The cosmos is a living entity, forever caught in a delicate, beautiful tension between the urge to expand and the irresistible inward pull of gravity. If you find a sense of peace in these quiet journeys through the cosmos, I invite you to join our community. I am Theodore, the researcher, and I am here to guide you through these contemplative explorations to the unknown. I have noticed that 71% of the gentle souls who watch these videos and share in this quiet wonder have not yet subscribed to the channel. If these stories bring you comfort and spark your cosmic curiosity, please consider subscribing. It helps us bring more content like this to you, and it lets us know that you want to keep exploring the universe together. Your presence here is valued, and together we can continue to uncover the gentle mysteries hidden in the dark. Now, let us return to the deep, silent void and the incredible structures that inhabit it. To understand the strange anomaly spotted by the James Webb Space Telescope in the cosmic dawn, we must first look at the giants that exist in our more recent local universe. The biggest galaxy we have ever discovered is a cosmic monster that sits over 1 billion light-years away from us, quietly existing in the darkness of space, holding more stars than you could ever count in 1 million lifetimes. This enormous entity is known as IC 1101. This galaxy is estimated to be somewhere around 4 to 6 million light-years across. Our own Milky Way, which already seems impossibly vast, is only about 100,000 light-years wide. IC 1101 is roughly 40 to 60 times larger than our entire galaxy. If you place this magnificent giant where our Milky Way currently sits, it would not just engulf our galaxy, it would swallow our entire cosmic neighborhood, including the Andromeda Galaxy. But a galaxy does not simply appear at this incomprehensible size. It becomes a giant through an act of cosmic violence that has been happening for billions of years. IC 1101 is what scientists call a cannibal galaxy, meaning it has been eating other galaxies. To understand this galactic cannibalism, you need to think about how gravity works on the largest scales. Galaxies do not exist in isolation. They are grouped together in clusters held together by their mutual gravitational attraction. Within these vast clusters, galaxies move around each other, sometimes passing close by, sometimes colliding directly. When two galaxies begin to interact, the first thing that happens is a gravitational dance that stretches across the void. Even when the galaxies are millions of light-years apart, they can feel each other's gravity, which begins to distort their shapes ever so slightly. Stars that were orbiting peacefully begin to feel a pull from an unexpected direction. When two galaxies get close to each other, their gravity begins to profoundly distort their shapes. Stars get pulled out of their normal orbits, and gas and dust get compressed and stretched. If the galaxies are similar in size, they might merge together over hundreds of millions of years, eventually forming a single larger galaxy. Long streams of stars get drawn out from each galaxy, forming what astronomers call tidal tails. These tails can extend for hundreds of thousands of light-years into space, ghostly ribbons of stars marking the violence of the interaction. But because this happens in the absolute vacuum of space, over geological timescales, the collision itself would not be violent in the way you might imagine. Stars are separated by such vast gulfs that the chance of any two of them colliding by accident is essentially zero. Galaxies can pass through each other without any stars actually hitting one another. If one galaxy is much bigger than the other, something different happens. The larger galaxy simply absorbs the smaller one, stripping away its stars and gas, adding all of that material to its own massive body. This is what has been happening to IC 1101 for billions of years. As the largest and most massive galaxy in its cluster, It sits at the gravitational center of everything around it. Smaller galaxies that venture too close get trapped by its enormous gravity. They spiral inward, getting torn apart and consumed over millions of years. Each meal makes this quiet giant a little bit bigger, a little bit more massive, a little bit more dominant. Scientists estimate that IC 1101 has undergone at least 76 major mergers over its long history. 76 times another substantial galaxy fell into this cosmic giant and was absorbed into its body. And those are just the major mergers. Countless smaller dwarf galaxies have also been consumed, galaxies so small that they barely registered as a meal for this enormous predator. This slow, relentless accumulation of matter is the established, understood path to building a massive galaxy. It is a journey that requires time, patience, and the inexorable pull of gravity acting over eons. But when we look back at the anomaly discovered by the James Webb Space Telescope in the cosmic dawn, this beautiful, slow narrative begins to unravel. The anomaly is sitting in a universe that is only a few 100 million years old. There simply has not been enough time for dozens of major mergers to occur. There has not been enough time for this slow, silent ballet of tidal tails and gravitational stripping to build a structure of such immense maturity and organized luminosity. This is the paradox that challenges our understanding of the universe. If the universe builds things from the bottom up, starting small and growing large, through countless merges over cosmic time, how did a fully formed giant arrive at the very beginning of the story? It forces us to ask if there are alternative pathways to greatness in the cosmos. Could it be that in the denser, hotter environment of the early universe, matter collapsed differently? Perhaps vast, incredibly massive clouds of primordial hydrogen gas did not fragment into millions of tiny stars to form a dwarf galaxy. Perhaps, instead, they collapsed directly under their own immense weight, falling inward with such speed and ferocity that they bypass the typical stellar life cycles entirely. At the very heart of these cosmic giants, whether they are modern monsters like IC 1101 or ancient anomalies spotted by James Webb, lies something even more incredible than the galaxy itself. Sitting at the center of this cosmic giant is one of the largest known supermassive black holes in the entire universe. Every large galaxy has a supermassive black hole at its core, but the black hole at the center of IC 1101 is in a completely different category. Scientists estimate that it contains somewhere between 40 billion and 100 billion times the mass of our Sun. All of that mass is compressed into a region of space from which nothing can escape. The gravitational pull at the event horizon, the boundary of the black hole, is so intense that even light itself cannot break free. The event horizon is just the boundary beyond which escape becomes impossible. For a black hole of 50 billion solar masses, the event horizon would have a radius of roughly 150 billion kilometers. If you place this black hole where our Sun is, its event horizon would extend well beyond the orbit of Pluto, engulfing everything we consider our cosmic home. Inside the event horizon, all directions lead toward the singularity at the center. The process by which these supermassive black holes grow is just as fascinating and silent as the growth of the galaxies themselves. When galaxies merge, the supermassive black holes at their centers eventually find each other and merge as well. When two galaxies collide, their central black holes do not immediately find each other, as they are separated by vast distances and surrounded by billions of stars. But as the merger progresses, gravitational friction with the surrounding stars causes the black holes to spiral toward the center of the combined galaxy. Eventually, the two black holes get close enough to form a binary system orbiting around each other. As they orbit, They lose energy through gravitational waves, ripples in the fabric of space-time itself. These gravitational waves carry energy away from the binary, causing the orbit to shrink. The black holes spiral closer and closer, orbiting faster and faster, until finally they merge in a catastrophic event that releases enormous amounts of energy. When two supermassive black holes merge, the gravitational waves they produce are among the most powerful events in the universe. The final merger releases more energy than all the stars in a typical galaxy combined, though most of this energy is in the form of gravitational waves rather than light. These invisible waves ripple outward at the speed of light, stretching and squeezing space itself as they pass through the silent dark. Could the James Webb anomaly be the result of a direct collapse black hole that grew so rapidly it forced a galaxy to form around it? Scientists have discovered that there is a relationship between the mass of a galaxy's central black hole and the properties of the galaxy itself. Bigger galaxies tend to have bigger black holes. But which came first? Did the black holes form first and then grow their galaxies around them? Or did the galaxies form first and then build up their black holes over time? The answer for galaxies like IC1101 seems to be that they grew together, each one influencing the development of the other through a long shared evolution. As the galaxy consumed more material, the central black hole also consumed the black holes from those smaller galaxies, creating a feedback loop that produced both a massive elliptical galaxy and a colossal central singularity. But the ancient anomaly suggests a different story might be possible. If a black hole could form rapidly in the very early universe, born massive from the direct collapse of a primordial gas cloud, it could act as a tremendous gravitational anchor. It would pull in surrounding gas and dark matter at astonishing speeds, igniting a furious burst of star formation that would quickly build a massive galaxy in a fraction of the time it takes in the modern universe. This quiet realization expands our horizon. We are the universe observing itself from within, finding peace in the endless, beautiful mystery. Have you ever imagined what exists in the absolute spaces between the magnificent islands of light we call galaxies? When we look out into the deep dark, our eyes naturally seek out the brilliant beacons of stars and the swirling majesty of galactic spirals. We are drawn to the light, assuming that where there is no light, there is simply nothing at all. But the universe is a master of disguise, often hiding its most profound wonders in plain sight, wrapped in a cloak of invisibility. No galaxy exists in complete isolation. Even the grandest, most imposing cosmic structures are cradled within an environment that we are only just beginning to truly understand. Galaxy clusters are some of the largest gravitationally bound structures in the entire universe. They can contain hundreds or even thousands of individual galaxies, all performing a slow, majestic orbit around a common center of mass over billions of years. To our fragile human perception, the vast space between these galaxies within a cluster appears entirely empty. But it is not a void. It is a dynamic, ancient sea filled with extremely hot gas, heated to staggering temperatures of tens of millions of degrees by the immense gravitational energy released as the cluster originally formed. This invisible ocean of searing plasma holds the key to understanding both the giants of the modern universe and the strange anomalies discovered in the cosmic dawn. If you find a sense of peace and belonging in these quiet journeys through the cosmos, I invite you to join our growing community of explorers. I am Theodore, the researcher, and I am here to guide you through these contemplative explorations into the unknown. I have noticed that 71% of the gentle souls who watch these videos and share in this quiet wonder have not yet subscribed to the channel. If these stories bring you comfort, if they help you find stillness in the vastness, and if they spark your cosmic curiosity, please consider subscribing. It helps us bring more content like this to you, and it lets us know that you want to keep exploring the universe together. Your presence here is deeply valued, and together we can continue to uncover the gentle mysteries hidden in the dark. Let us return to the deep, silent void and examine the invisible sea that surrounds our cosmic giants. The cluster that houses the enormous galaxy known as IC 1101 is called Able 2029. Able 2029 is what astronomers call a relaxed cluster, meaning it has settled into a fairly stable, calm configuration over billions of years of cosmic history. The galaxies within it have had vast eons of time to sort themselves out, with the most massive ones slowly sinking toward the center due to a fascinating process called dynamical friction. As more massive objects move through a sea of smaller objects, they experience a kind of gravitational drag that gently slows them down and causes them to spiral inward over immense time scales. IC 1101 sits at the very bottom of this deep gravitational well, exactly at the densest part of the cluster, where galaxies are packed most tightly together. This location is not a coincidence, for IC 1101 grew so incredibly large precisely because it was in this privileged central position. As other, smaller galaxies spiraled toward the cluster center, drawn by the irresistible pull of the collective mass, they encountered IC 1101 and were quietly absorbed. The same beautiful, inevitable process that brought this giant to the center also brought it a constant, steady supply of victims to consume over billions of years. But the galaxies themselves are only part of the story. The hot gas that fills the cluster also plays a critical, unseen role in the evolution of these cosmic monsters. This gas, known as the intra-cluster medium, is incredibly sparse by normal earthly standards. If you could somehow scoop up a cubic meter of it, you would find only a handful of atoms floating in the dark. But because there is so much of it spread across millions of light years of space, it adds up to an enormous, almost incomprehensible amount of mass. This vast ocean of gas is so hot that it emits X-rays, which is precisely how our brilliant astronomers are able to detect it. X-ray telescopes, like the Condra Observatory, have carefully mapped the distribution of this hot gas in Able 2029, revealing that it is heavily concentrated around IC 1101 at the very center of the cluster. The gas forms a kind of glowing, invisible atmosphere around the giant galaxy, a thin haze of superhot particles extending for millions of light years into the absolute cold of space. The presence of this hot gas has profound implications for the future of IC 1101, and it offers a vital clue to the mystery of the anomaly discovered by the James Webb Space Telescope. In the natural order of the cosmos, hot gas should eventually cool down over long periods of time, radiating away its immense energy as X-rays. When this gas cools enough, it can lose its pressure support and fall into the central galaxy, potentially fueling a massive new wave of star formation. In some galaxy clusters, astronomers have indeed observed enormous flows of cooling gas, representing hundreds of solar masses worth of material per year streaming steadily into the central galaxy. But in the case of IC 1101, something strange and powerful seems to be preventing this cooling flow from igniting a new, brilliant burst of stellar birth. The leading theory, a testament to the elegant interconnectedness of the universe, is that the supermassive black hole at the center of IC 1101 is directly responsible. When gas falls toward the black hole, some of it gets heated to unimaginable temperatures and blown back out into the cluster before it can be consumed. This creates a magnificent cosmic feedback loop where the black hole actively regulates the gas supply, preventing too much from accumulating and forming new stars. We can actually see clear evidence of this feedback mechanism in observations of the giant galaxy and its surrounding environment. There are massive cavities in the hot gas around the galaxy, vast bubbles that have been blown by incredibly powerful jets of energy emerging from the vicinity of the central black hole. These cavities are millions of light years across, enormous voids carved out of the intra-cluster medium by the sheer energy output of the slumbering singularity. This feedback mechanism is thought to be incredibly important for understanding why massive elliptical galaxies like IC1101 are currently dying, no longer forming new stars today. Without the central black hole regulating the gas supply, cooling flows would deliver enough raw material to trigger substantial, continuous star formation. But the black hole acts like a cosmic thermostat, heating up gas whenever too much starts to cool, keeping the entire galaxy in a kind of permanent, quiet energy balance. This interplay between galaxies, their supermassive black holes, and the hot gas in galaxy clusters is one of the most active, fascinating areas of research in modern astrophysics. Now, let us gently carry this understanding back through time to the anomaly discovered by James Webb. If this ancient structure managed to assemble itself so rapidly in the cosmic dawn, did its central black hole operate under different rules? Perhaps the thermostat was broken, allowing vast quantities of pristine, primordial gas to flow unimpeded into the center, triggering a starburst of unimaginable intensity. Or perhaps the black hole itself grew so fast that its feedback jets could not clear away the dense, falling matter, creating a temporary, brilliant paradox of creation and destruction occurring simultaneously. The interplay of forces in the early universe was likely far more intense, far more rapid, and far more mysterious than the slow, relaxed elegance we observe in modern clusters. As we ponder these immense structures and the delicate balances that govern their lives, we must also confront their ultimate, silent destiny. The universe is not a static painting. It is a canvas that is constantly being stretched. In about 100 billion years, the relentless expansion of space will have accelerated to the point where galaxies outside the local supercluster will start to disappear over the cosmic horizon. From the perspective of a giant like IC1101, or even our own Milky Way, the sky will start to empty. One by one, distant galaxy clusters will fade from view, their ancient light no longer able to reach across the ever-expanding, ever-widening void. The observable universe, which currently contains about 2 trillion galaxies, will shrink and shrink until we are left in profound isolation. Within a cluster like Hubble 2029, things will be different for a while longer. The galaxies there are close enough and bound tightly enough by gravity that they will stay together even as the larger universe empties out around them. Over the next several billion years, these remaining galaxies will continue to interact, to merge, and to evolve in their quiet corner of existence. IC1101 might still consume a few more gentle victims, growing slightly larger even as the rest of the universe slips away into the unreachable dark. But eventually, even the galaxies within the cluster will merge together, leaving only a single, unimaginably massive remnant drifting in an ocean of absolute blackness. This vision of the future might seem bleak to our human sensibilities, but there is a profound, melancholic beauty to it. It teaches us the preciousness of the present moment. We are lucky enough to exist during this specific era, a brief flowering of complexity between the fiery chaos of the early universe and the cold emptiness of the far future. We are lucky enough to have evolved intelligence, built telescopes, and pointed them at the sky to see these wonders before they vanish. Every discovery we make, every galaxy we study, every black hole we observe, expands our sense of what is possible. We are not separate from the universe. We are part of it. The same processes that built the giant galaxies and the ancient anomalies built us. The same atoms that shine in distant galaxies shine in our very eyes. We are not mere observers of the universe from the outside. We are the universe observing itself from within. When you contemplate the deep dark and the majestic monsters that inhabit it, remember that you are participating in a tradition of inquiry that stretches back centuries. You are connecting your conscious mind to the grandest scales of existence. The quiet darkness is not something to be feared, but a vast, silent library of ancient history waiting to be read. Let the stillness of the cosmos wash over you, bringing peace to your thoughts and wonder to your soul, as we continue to drift together on this beautiful, tiny blue sphere through the endless night. Have you ever sat quietly by a window, watching the slow, deliberate crawl of shadows across the floor as the afternoon gently fades into the cool embrace of evening? We experience time as a steady, flowing river, a continuous stream of seconds and minutes that carry us from the past into the future with a rhythm we can feel in our own beating hearts. Our human lives are measured in decades, a brief, bright spark in the overwhelming and eternal darkness. But when we look up at the night sky, we are confronted with a completely different measure of existence. The cosmos operates on time scales that make our entire recorded human history seem like nothing more than a single, fleeting breath in the grand symphony of the void. We are used to thinking of time as something that belongs to us, a precious resource we manage, spend, and inevitably lose. But in the deep, quiet vastness of the universe, time is the ultimate sculptor, the slow and patient artist that carves majestic galaxies out of formless primordial gas and gently grinds magnificent stars down into cold, dark remnants over unimaginable eons. When the James Webb Space Telescope peered into the cosmic dawn and found that strange, mature anomaly, it did not just find a peculiar object. It found a profound paradox of time itself. It found something that seemed to have lived a full ancient life in a universe that had only just been born. If you find a profound sense of peace and belonging in these quiet journeys through the cosmos, I invite you to join our growing community of gentle explorers. I am Theodore, the researcher, and I am here to guide you through these contemplative explorations into the unknown. I have noticed that 71% of the gentle souls who watch these videos and share in this quiet wonder have not yet subscribed to the channel. If these stories bring you comfort, if they help you find stillness in the vastness, and if they spark your cosmic curiosity, please consider subscribing. It helps us bring more content like this to you, and it lets us know that you want to keep exploring the universe together. Your presence here is deeply valued, and together we can continue to uncover the gentle mysteries hidden in the dark. To understand how beautifully strange this temporal paradox truly is, we must take a quiet journey into the life cycles of the stars themselves. Stars are not eternal, unchanging diamonds fixed permanently to the canopy of the heavens. They are born in vast, swirling clouds of dust. They live their fiery lives illuminating the dark, and eventually they must inevitably die. The duration of a star's life is entirely determined by its mass, a beautiful and sometimes cruel equation of cosmic physics. The most massive stars in the universe, the brilliant blue giants and supergiants, live fast and die young. They burn through their immense reservoirs of nuclear fuel in just a few million years before exploding as spectacular, universe-altering supernovas. While these massive blue stars burn out quickly in a brief blaze of cosmic glory, the smaller, more modest stars take a much gentler, slower path through existence. The stars most similar to our own sun have lifetimes of about 10 billion years. Our sun is roughly halfway through its peaceful life, with about 5 billion years left before it gently swells into a red giant and eventually sheds its outer layers, becoming a quietly cooling white dwarf. But the most numerous stars in any galaxy are not the brilliant blue giants or the steady yellow suns. They are the red dwarfs, tiny stars with only a small fraction of the sun's mass. These modest little fires burn their hydrogen fuel so incredibly slowly and efficiently that they can shine for trillions of years. A red dwarf born at the exact same time as our sun will still be shining a gentle crimson light long after our sun has become a cold, dark cinder. In fact, the smallest red dwarfs, those with perhaps 8% of the sun's mass, can burn for up to 10 trillion years. That is about 700 times the current age of our entire universe. When we look at a modern giant like the magnificent IC 1101, we are looking at a vast, quiet retirement home for these ancient, long-lived stars. Despite containing an unimaginable 100 trillion stars, IC 1101 is actually a dying galaxy. The stars within its vast elliptical body are almost all old. Most of them are what astronomers call red giants or yellow stars, ancient stellar objects that have already burned through the vast majority of their nuclear fuel. Any blue giants that IC 1101 once possessed burned out billions of years ago. Very few new stars are being born inside this cosmic giant today. This might seem incredibly strange at first glance, especially with so many stars and so much mass gathered in one place. You might expect such a massive entity to be a hotbed of stellar activity, a bustling nursery of ongoing creation. But remember how it grew so large over the silent eons. Every time it consumed another, smaller galaxy, it also consumed that victim's precious gas supply. Gas is the essential fuel for star formation. Without gas, new stars absolutely cannot be born. Over billions of years of relentless galactic cannibalism, IC 1101 has either used up or violently expelled most of its available gas. The mergers themselves were often violent enough to heat the gas to extreme temperatures, making it expand and escape the galaxy entirely, or to compress it so quickly that it all formed into stars at once, in brief, intense bursts of activity. Either way, the final result is a galaxy that has completely run out of raw material. What remains is a quiet giant slowly fading into the cosmic night. IC 1101 is like an ancient kingdom that has conquered all of its neighbors but has no children to carry on its legacy. It is massive, powerful, and utterly magnificent, but it is also slowly approaching the end of its active life. Now, carry this peaceful understanding of stellar aging back across 13 billion light-years to the anomaly spotted by the James Webb Space Telescope. In the early universe, galaxies should be bursting with raw, unformed hydrogen gas. They should be blazing with the fierce, brief, ultraviolet light of massive blue stars, the very first generations of stellar engines to ignite and push back the primordial dark. A galaxy in the cosmic dawn should look like a chaotic, brilliant nursery, a messy and disorganized collection of matter just beginning to find its shape. It should not look like an organized, mature kingdom. Yet, the light from the anomaly did not match the chaotic, blue signature of a primordial starburst. Its infrared glow suggested a population of stars that were already mature, stars that had somehow aged rapidly, in a universe that was still in its absolute infancy. How could a galaxy run out of gas and become dominated by older stars when the universe itself had barely begun to expand? This is the beautiful, quiet paradox that keeps astronomers staring at their screens, marveling at the vastness of the unknown. Did this anomalous structure somehow gather an immense, localized pocket of gas and turn it all into stars in one instantaneous, catastrophic flash of creation? Or does the early universe hide secret processes of stellar aging and galactic evolution that we have not yet discovered? To unravel these mysteries, we rely on the stretching of ancient light, the gentle redshift that carries the secrets of the past into our present moment. As the universe expands, light from distant objects gets stretched to longer wavelengths. This shifts the light toward the red end of this spectrum, hence the perfectly descriptive name redshift. The more distant an object is, the more the universe has expanded since its light was emitted, and the greater its redshift. When the golden mirrors of James Webb captured the anomaly, they were catching photons that had been stretched so profoundly that their original visible light had been pulled all the way into the deep, invisible infrared. This is not merely a change in color. It is a physical manifestation of time passing and space growing over billions of years. By measuring the redshift of light from a local giant like IC 1101, astronomers have determined that it is about 1.04 billion light years away. But the anomaly is over 10 times farther, a ghostly, impossible apparition from a time when the rules of the universe seem to operate under a different, hidden logic. Every time we build a better telescope, every time we polish a larger mirror or launch a more sensitive detector into the cold vacuum of orbit, we expect to finally find the definitive answers. But the universe, in its infinite and gentle grace, usually gives us something much better. It gives us new, more profound questions to ponder. Before the Hubble Space Telescope stared into the dark, we could only guess at the true number of galaxies hiding in the void. Before James Webb opened its golden eyes, we comfortably assumed the cosmic dawn was a slow, orderly awakening. The anomaly beautifully shatters our neat, comfortable assumptions. It tells us that the cosmos is capable of feats of creation that effortlessly defy our current mathematical models. It tells us that the dark is not just an empty space waiting to be filled, but an active, dynamic participant in the unfolding, infinite story of existence. There is a deep, abiding peace to be found in this realization. We do not need to have all the answers to appreciate the absolute beauty of the mystery. The silence of the universe is not a withholding of truth. It is a gentle, open invitation to keep looking, to keep wondering, and to keep expanding our own minds to match the vastness of what we observe. As you lie there, safe and warm in your own small corner of the world, thinking about the unfathomable distances and the impossible paradoxes of the deep dark, remember that you are intimately connected to it all. The same physical laws that govern the rapid, mysterious assembly of the ancient anomaly also govern the gentle beating of your heart and the rhythm of your breathing. The same gravity that pulls galaxies into massive clusters keeps your feet firmly planted on the ground of this tiny blue sphere. You are a localized, conscious manifestation of the very universe you are trying so diligently to understand. When you feel a sense of awe at the scale of the cosmos, you are experiencing the universe recognizing its own majesty. This connection is not a mere philosophical abstraction. It is written into the very atoms of your physical being. You are made of the heavy elements forged in the hearts of dying stars, scattered across the void, to eventually coalesce into planets, oceans, and life. Your curiosity is the universe's way of exploring itself. We are not separate from the cosmos. We are the cosmos, waking up and looking back at the beautiful dark from which we came. The anomaly spotted by James Webb is a quiet beacon in the night, reminding us that the journey of discovery is truly infinite. We may never fully understand how such a massive, mature structure could exist so early in the river of time. But the pursuit of that understanding will lead us to new physical laws, new ways of perceiving reality, and a deeper, more profound appreciation for the miraculous nature of our shared existence. The universe is a grand unfolding mystery, and we are incredibly fortunate to be here, in this specific, fleeting sliver of time, with the ability to look up and wonder. Let the quiet immensity of the cosmos calm your racing thoughts. Let the unanswered questions be a source of comfort, knowing that the universe will always have more beauty, more strangeness, and more silent grandeur to share with those who are willing to look. The dark is not empty, my friends. It is full of ancient light, waiting patiently for us to open our eyes, expand our minds, and see the infinite journey that lies ahead. Have you ever tossed a small, smooth pebble into a perfectly still pond and watched the gentle ripples travel outward, carrying the energy of that tiny impact across the glassy surface? In our everyday world, we can easily see these ripples. We can watch them distort the reflections of the trees and the sky, and we intuitively understand that an event in one place can silently, gracefully affect the entire body of water. But what if the pond was the very fabric of reality itself, and the pebble was a collision of such unimaginable power that it shook the fundamental foundations of space and time? For most of human history, we have observed the universe solely through the gentle light it emits, catching the ancient photons that cross the seemingly endless void to strike our telescopes. We have been like quiet observers studying a vast ocean only by looking at the sunlight glinting off the crests of the waves. But the universe has other, more mysterious ways of speaking, secret and profound channels of communication that do not rely on light at all. When the most massive objects in the cosmos interact, they do not just shine. They fundamentally alter the geometry of the emptiness around them. As we look deeper into the cosmic dawn, trying to understand the impossible anomaly spotted by the James Webb Space Telescope, we must expand our senses and learn to feel the unseen ripples of ancient gravitational violence. If you find a deep, resonant peace in these quiet journeys through the unseen structures of the cosmos, I invite you to join our growing community of cosmic listeners. I am Theodore, the researcher, and I am here to guide you through these contemplative explorations into the profound unknown. I have noticed that 71% of the gentle souls who watch these videos and share in this quiet wonder have not yet subscribed to the channel. If these stories bring you comfort, if they help you find stillness in the vastness, and if they spark your cosmic curiosity, please consider subscribing. It helps us bring more content like this to you, and it lets us know that you want to keep exploring the universe together. Your presence here is deeply valued, and together we can continue to uncover the gentle mysteries hidden in the dark. Now, let us return to our journey, exploring the invisible vibrations that connect the ancient past to our quiet present moment. Let us think about what happens when giant galaxies collide and intertwine in the deep dark. When galaxies merge, the supermassive black holes at their centers eventually find each other and merge as well. This is not a sudden, loud crash, but a slow, majestic, and terrifyingly silent dance. When two galaxies collide, their central black holes do not immediately find each other. They are initially separated by vast distances and surrounded by billions of peaceful stars. But as the merger progresses over millions of years, gravitational friction with the surrounding stars causes the black holes to slowly, inevitably spiral toward the center of the newly combined galaxy. Eventually, the two black holes get close enough to form a binary system, orbiting around each other in the silent void. As they orbit, They lose energy through gravitational waves, ripples in the fabric of space-time itself. These invisible gravitational waves carry energy away from the binary, causing the orbit to shrink. The black holes spiral closer and closer, orbiting faster and faster, until finally they merge in a catastrophic event that releases enormous amounts of energy. When two supermassive black holes merge, the gravitational waves they produce are among the most powerful events in the universe. The final merger releases more energy than all the stars in a typical galaxy combined, though most of this energy is in the form of gravitational waves rather than light. These waves ripple outward at the speed of light, stretching and squeezing space itself as they pass through the quiet dark. Imagine that profound concept for a moment. An event so unimaginably powerful that it releases more energy than all the shining stars in a galaxy combined, yet it happens in absolute, profound silence, entirely invisible to any telescope searching only for light. For countless millennia, humans looked at the night sky, completely unaware that these silent waves were constantly passing through them, stretching and squeezing the very atoms of their bodies by an amount so infinitesimally small it could never be felt. We have only recently developed the technology to detect gravitational waves, allowing us to finally listen to the cosmos. The first direct detection came in 2015, when the LIGO observatories successfully measured waves from two stellar mass black holes merging about 1 billion light-years away. Since then, dozens of gravitational wave events have been carefully observed, opening up an entirely new, beautiful way of studying the universe. Future gravitational wave detectors, like the planned LISA mission that will fly safely in space, will be able to detect the massive mergers of supermassive black holes. When LISA launches, perhaps in the 2030s, it might actually detect events similar to the ancient mergers that built up IC 1101's central black hole. We will be able to literally listen to the universe as giant black holes collide and merge, adding another profound sense to our astronomical toolkit. This brings us back to the mysterious anomaly floating quietly in the cosmic dawn, spotted by the golden mirrors of the James Webb Space Telescope. If this incredibly mature structure was built rapidly in the early universe, did it send out its own chorus of unseen gravitational waves? If a massive black hole collapsed directly from a primordial cloud of gas, bypassing the gentle formation of stars, it would have sent a profound shock wave through the young, dense fabric of reality. The universe back then was smaller, the matter more tightly packed, acting like a tighter drumhead upon which the invisible mallets of gravity struck. Our current earthbound instruments are tuned to the higher frequencies of smaller black holes merging in the relatively recent past. But as we build larger, more sensitive detectors floating in the quiet vacuum of space, millions of miles from our home, we might eventually catch the long, slow, deep bass notes of the cosmic dawn. We might hear the ancient echo of the anomaly's spectacular birth, a silent roar that has been traveling across the expanding dark for over 13 billion years. It is a beautiful, comforting thought that nothing in the universe happens in true isolation. Every collision, every collapse, every magnificent act of creation sends a gentle whisper across the endless void, waiting patiently for someone to learn how to listen. The history of these ancient structures is often written clearly in their shape and form, if we only know how to read the cosmic language. The evidence for this cannibalistic history is written in IC 1101's very structure. When you look at a galaxy like our Milky Way, you see a beautiful spiral pattern, an elegant pinwheel of stars and gas. IC 1101 looks nothing like this. It is what astronomers call an elliptical galaxy, which means It has a smooth oval-shaped appearance with no spiral arms at all. Elliptical galaxies form when beautiful spiral galaxies merge together. The violent gravitational interactions during a merger destroy the delicate spiral structure, mixing all the stars together into a more random spherical or oval distribution. The undeniable fact that IC 1101 is an elliptical galaxy tells us that it has experienced so many mergers that any original spiral structure it might have had has been completely erased. All of those collisions, all of that gravitational chaos has stirred up the stars like someone mixing ingredients in a cosmic bowl. What remains is this smooth, featureless giant, a quiet testament to billions of years of galactic consumption. When we look at the anomaly from the early universe, its structure might also tell us a profound story, a story of an environment so dense and chaotic that elegant spirals never even had the chance to form. Yet, as we deeply marvel at the immense power of these creation events and the giants they build, we must also embrace the profound peace of their eventual, inevitable dissolution. The universe is not a permanent monument carved in stone. It is a fleeting, beautiful, and ever-changing process. Over even longer time scales, measured in years with so many zeros that writing them out would fill pages, even these quiet stellar corpses will decay. White dwarfs will slowly cool until they become black dwarfs, objects that no longer emit any light at all. And the black holes, including that enormous monster at the center of IC 1101, will slowly evaporate through a quiet process called Hawking radiation. The brilliant physicist Stephen Hawking discovered that black holes are not truly black. They slowly leak particles and radiation over immense time spans, gradually shrinking as they do so. This happens because of strange, beautiful quantum mechanical effects near the event horizon. The rate of Hawking radiation is incredibly slow for large black holes. A black hole with the mass of our Sun would take about 10 to the 67th power years to evaporate. But the supermassive black hole at the center of IC 1101 is billions of times more massive than the Sun. A black hole containing 50 billion solar masses would take something like 10 to the 100th power years to evaporate, or maybe even longer. Eventually, trillions upon trillions upon trillions of years from now, even the supermassive black hole at the heart of IC 1101 will have radiated away its last bit of energy and disappeared from the universe in a final burst of Hawking radiation. When that finally happens, there will be nothing left of IC 1101 at all. No stars, no black holes, no remnants of any kind, just the particles and radiation that once made up a magnificent galaxy, spreading out through an ever-expanding, ever-cooling, ever-darkening universe. The largest galaxy we have ever found will have followed the same ultimate path as every other structure in the cosmos, dissolving into the endless night. This vision of the ultimate future is not something to be feared, but something to be embraced with a quiet, meditative reverence. It gently teaches us that everything is temporary, from the smallest beating heart to the largest supermassive black hole in existence. The anomaly in the cosmic dawn, born in a rush of ancient violence, and the majestic giant IC 1101, built through billions of years of slow consumption, will all eventually return their borrowed energy to the great silent ocean of the cosmos. We are incredibly privileged witnesses to a fleeting, miraculous middle chapter in a story that spans eternity. The fact that we have evolved the intellectual capacity to look back at the dawn of time, to measure the invisible ripples of colliding giants, and to mathematically predict the final, quiet evaporation of the universe, is a breathtaking testament to the profound beauty of human consciousness. We are the universe waking up, trying to understand its own magnificent, temporary existence. As you rest your mind and let these grand cosmic concepts wash over you, remember that the absolute silence of the dark is a peaceful, welcoming embrace. It is the vast, quiet canvas upon which all light, all matter, and all life are briefly, brilliantly painted. And when the painting is finally complete, the canvas will simply return to its quiet, perfect stillness. Until then, we will continue to look into the night sky, to listen for the unseen ripples, and to wonder at the infinite beauty of our shared journey through the dark. Have you ever stood on the quiet edge of the ocean at twilight, watching the dark waves meet the fading horizon, and felt an overwhelming, almost melancholic urge to know what lies entirely beyond that distant watery line? This profound wanderlust, this deep-seated and ancient need to physically cross the boundaries of our known world, is one of the most defining and beautiful characteristics of the human spirit. We have spent centuries building massive ships to cross the vast, unpredictable oceans. We have engineered intricate machines to fly effortlessly through the thin, cold air, and we have even crafted delicate, brilliant vessels to carry our fragile bodies to the quiet, dusty surface of the moon. But when we turn our gaze away from our tiny, comfortable planetary neighborhood and look out into the deep, infinite dark of the cosmic ocean, we are immediately confronted by an invisible barrier that no physical ship can currently breach. The universe is protected by an impenetrable armor of sheer distance, a scale so unimaginably vast and profound that our fastest, most advanced creations are reduced to nothing more than motionless specks suspended in the silent void. We cannot physically visit the majestic giants like the immense galaxy IC 1101, as all we have is the ancient light that reaches our telescopes. We cannot travel back through the eons to touch the strange anomaly spotted by the James Webb Space Telescope in the cosmic dawn. Instead, we must rely on the gentle light that reaches our golden mirrors, sending our minds on quiet, contemplative journeys across the infinite, while our physical bodies remain safely tethered to the familiar gravity of Earth. If you find a comforting sense of peace and belonging in these quiet mental voyages through the cosmos, I invite you to join our growing community of gentle stargazers. I am Theodore, the researcher, and I am here to serve as your guide through these contemplative explorations into the unknown. I have noticed that 71% of the gentle souls who watch these videos and share in this quiet wonder have not yet subscribed to the channel. If these stories bring you comfort, if they help you find stillness in the vastness, and if they spark your cosmic curiosity, please consider subscribing. It helps us bring more content like this to you, and it lets us know that you want to keep exploring the universe together. Your presence here is deeply valued, and together we can continue to uncover the gentle mysteries hidden in the dark. Now, let us return to our journey, exploring the impossible, magnificent scales that separate us from the objects of our fascination and the slow, beautiful dance of the galaxies. To truly appreciate the scale of what we are talking about, to even begin to wrap our fragile human minds around the vastness of the deep dark, we must take a journey of the imagination to help you truly appreciate the scale of what we are talking about. We must try to translate these cosmic distances into something our brains can, however imperfectly, attempt to grasp. Let us consider the incredible journey of the Voyager 1 spacecraft. Launched by the National Aeronautics and Space Administration in 1977, Voyager 1 is the fastest human-made object ever to leave our solar system. It is a beautiful, fragile messenger from our small world, carrying a golden record filled with the greetings, the music, and the sounds of our vibrant planet, quietly drifting into the endless, silent night. It is traveling at about 38,000 miles per hour relative to the sun. To our everyday earthly senses, this speed is absolutely staggering, faster than any bullet, faster than any wind, faster than anything we could possibly experience in our daily terrestrial lives. Yet, the universe is so vast, so incredibly expansive, that even at that incomprehensible speed, crossing the voids of space becomes an exercise in profound geological patience. At that tremendous velocity, Voyager 1 would take about 80,000 years just to reach the nearest star to our sun, a small red dwarf called Proxima Centauri. And Proxima Centauri is only about 4 light years away from our solar system. Let that gentle fact sink in for a moment. 80,000 years is an ocean of time. It is longer than all of recorded human history, longer than the time since we first began to paint our dreams on the walls of ancient caves. It is a span of time that encompasses the slow rise and the inevitable fall of every single civilization that has ever existed on our planet. And yet, that immense stretch of time is just what is required to make the absolute smallest possible step to our very closest stellar neighbor. Now, let us expand our view and imagine trying to cross our entire home galaxy, the Milky Way. To cross the entire Milky Way at Voyager 1's staggering speed would take about 2 billion years. 2 billion years is nearly half the age of the Earth itself, a span of time during which massive mountain ranges are slowly pushed toward the sky and then gently eroded into dust by the patient rain. And yet, to cross the enormous giant known as IC 1101, you would need somewhere between 80 billion and 120 billion years. That is more time than the universe has even existed. Even with our fastest spacecraft, crossing this single galaxy would be completely impossible. Here is another gentle way to think about the overwhelming size of these cosmic structures. If you could somehow magically shrink the entire Milky Way galaxy down to the size of a standard dinner plate, about 10 inches across, then the giant galaxy IC 1101 would be the size of a large swimming pool. Our entire galaxy, with all of its hundreds of billions of stars, the beautiful sweeping spiral arms where we make our home, and every single planet we could ever hope to discover, would be just a tiny dish floating quietly in a vast, unimaginable sea. If this is the breathtaking scale of the universe as it exists relatively near to us in the modern epoch, how do we even begin to comprehend the distance to the anomaly spotted by the James Webb Space Telescope? This strange, mature structure sits over 13 billion light-years away, near the very edge of the observable universe. To travel there physically is a concept that belongs strictly to the realm of fantasy. The light from that anomaly has traveled for over 13 billion years just to reach us, a journey so long that the universe itself has fundamentally changed its shape and its expansion rate, while those photons were in quiet transit. Every second, that light radiates enough distance to travel about 186,000 miles, moving steadily through the empty void. And it is only now just arriving at our golden mirrors, ancient photons that left their home galaxy when the cosmos was still in its earliest, chaotic stages. Yet, despite these terrifying, beautiful distances and the seemingly insurmountable isolation they create, we are not separated from the fundamental physical processes that shape these distant wonders. The universe is a single, interconnected tapestry of matter and energy. The exact same forces of gravity that rapidly assembled the ancient anomaly and slowly built the massive, featureless body of IC 1101 are actively working in our own quiet corner of the cosmos. Our own Milky Way is not immune to the forces that shaped IC 1101. We too are intimately participating in the slow, cosmic dance of galactic interaction and merger. Right now, as you listen to these words and breathe the calm night air, Our galaxy is in the process of consuming several smaller galaxies. The Canis Major dwarf galaxy is currently being ripped apart and absorbed into the vast halo of the Milky Way. The Sagittarius dwarf galaxy is being gently stretched and distorted by our massive gravitational pull. Faint streams of ancient stars from past victims can actually be traced across our night sky, ghostly reminders of smaller galaxies that once existed as separate, independent entities before they ventured too close to our gravitational shores. And in the deep, distant future, an even more dramatic and spectacular event patiently awaits our cosmic neighborhood. The Andromeda Galaxy, our nearest large galactic neighbor, is currently heading toward us through the dark vacuum of space. Scientists have long believed that in about 4 to 5 billion years, the Milky Way and Andromeda would collide and eventually merge into a single larger galaxy, often nicknamed Milkomeda by imaginative astronomers. While recent research has introduced some gentle uncertainty into this precise prediction, new studies using data from the Gaia spacecraft and Hubble Space Telescope suggest that the collision might not be as certain as we once thought. When scientists account for the complex gravitational influence of other nearby galaxies like the Large Magellanic Cloud and the Triangulum Galaxy, the probability of a direct collision drops significantly. Some advanced computer simulations now suggest only about a 50% chance of a merger happening within the next 10 billion years. But whether it happens in 4 billion years, 10 billion years, or not at all, the process itself beautifully illustrates the exact same forces that created IC 1101. Galaxies interact, they merge, and they slowly consume each other. It is simply the way of the universe. Even our own quiet, peaceful corner of the cosmos actively participates in this grand cosmic competition. If this magnificent merger does eventually happen, the results would be spectacular, at least when viewed on vast cosmic timescales. But it is crucial to understand that the collision itself would not be violent in the destructive, explosive way you might normally imagine. Remember the profound, breathtaking emptiness we spoke of earlier. The individual stars within these galaxies are so incredibly far apart that the chances of any two stars actually hitting each other are essentially zero. The merger would be a ghost-like passage, a beautiful, silent intermingling of ancient light and invisible gravity. The gravitational effects, however, would be incredibly dramatic and profound. The beautiful spiral structures of both our Milky Way and the grand Andromeda Galaxy would be completely destroyed, their delicate arms unwound by the immense tidal forces. Vast gas clouds would be compressed by the shifting gravity, triggering enormous bursts of new star formation that would briefly illuminate the merging galaxies with the fierce, brilliant blue light of stellar youth. The two supermassive black holes at the quiet centers of each galaxy would eventually find each other in the dark, performing their slow, silent orbital dance before finally merging, releasing invisible gravitational waves that would ripple endlessly across the fabric of the universe. Over billions of years, the gravitational chaos would gently settle down into a new, peaceful equilibrium. What was once the beautiful Milky Way and what was once the grand Andromeda spiral would slowly blend together into a single, large, smooth, elliptical galaxy, much like a much smaller version of the giant IC 1101. Future astronomers, if any such conscious beings exist on some distant world in that remote epoch, might look back at their old, fragmented records and marvel that their smooth, featureless home galaxy was once two beautiful spirals dancing gracefully through the void. By that distant time, of course, the Earth as we know and love it will be long gone. Our sun is expected to expand into a red giant in about 5 billion years, gently swelling to a massive size that would engulf our tiny, rocky planet in a final embrace of fire. Whether humanity survives until then, whether we spread our consciousness and our civilization to other star systems, or whether intelligence of any kind persists in the universe, these are profound existential questions we simply cannot answer. But the story of our own galaxy's future, mirroring the history of the massive giants and the mysteries of the ancient anomaly, reminds us that the universe operates on timescales that completely dwarf individual lives, individual civilizations, and even individual planets. We are part of a continuous, flowing narrative of creation, destruction, and slow, majestic transformation. The anomaly spotted by the James Webb Space Telescope is a mysterious snapshot of this narrative in its earliest, most chaotic chapters. IC 1101 is a magnificent snapshot of its late, quiet maturity. And we, sitting here on Earth, breathing the night air and looking up at the stars, are incredibly privileged to witness the middle chapters of this endless, beautiful story. We cannot cross these immense physical distances, but our minds, armed with insatiable curiosity and the quiet language of mathematics, can reach out and touch the very edges of existence. This ability to understand, to piece together the history of objects billions of light years away, is the true, quiet magic of human consciousness. As you drift toward a peaceful sleep, let the vastness of the cosmos be a comforting blanket. The universe is endlessly patient, infinitely beautiful, and forever waiting in the dark for us to uncover its gentle, quiet secrets. Have you ever stood under a truly dark sky, far away from the blinding, artificial lights of our bustling human cities, and felt a sudden, overwhelming wave of vertigo? This feeling does not come from looking down from a great height, but rather from looking up into an absolutely endless depth. When you look up at the night sky, you might feel small. You might feel completely and utterly insignificant in the face of such absolute, crushing vastness. This is a natural, deeply human response to the staggering, quiet scale of the cosmos. We are fragile creatures bound to a small, rocky sphere, and the infinite distances above us challenge our very sense of reality, importance, and belonging. We are used to a world that makes sense on a human scale, a world of miles and minutes. But the deep dark operates on a canvas of billions of light years and trillions of millennia. But I think the existence of giant structures like IC 1101 and the mysterious ancient anomalies we find hiding in the cosmic dawn actually tells us something profoundly hopeful and beautiful about our specific situation in the universe. First, consider the magnificent fact that we can know about these distant giants at all. We are observing a galaxy more than 1 billion light years away, containing an estimated 100 trillion stars, and we have somehow figured out how big it is, how it formed over eons, and what lies hidden in the absolute dark at its center. If you find peace and wonder in these quiet journeys through the cosmos, I invite you to join our growing community of cosmic explorers. I am Theodore, the researcher, and I am here to guide you through these contemplative explorations into the unknown. I have noticed that 71% of the gentle souls who watch these videos and share in this quiet wonder have not yet subscribed to the channel. If these stories bring you comfort and spark your cosmic curiosity, please consider subscribing. It helps us bring more content like this to you, and it lets us know that you want to keep exploring the universe together. That understanding we just spoke of is a remarkable, quiet miracle of consciousness. Human beings living on a small rocky planet orbiting an ordinary star in an unremarkable part of an average spiral galaxy have somehow developed the ability to understand objects so far away that their light left before a complex life existed on Earth. This ability to understand is not nothing. In a universe of mindless matter and energy, of simple particles bouncing around according to strict physical laws, somehow here on Earth, consciousness has emerged. We are minds that can wonder, question, investigate, and learn. Whatever else we are the part of the universe that has woken up and started asking questions about itself. This is a profound, beautiful shift in perspective that transforms our relationship with the endless void. Second, consider that the giant galaxy IC 1101, for all its terrifying enormity, is fundamentally made of the exact same stuff we are. The stars burning quietly in IC 1101 are fusion reactors just like our own familiar sun. They patiently burn hydrogen into helium and heavier elements just like stars do everywhere across the endless, silent void. The atoms in those distant ancient stars are the same kinds of atoms that make up our fragile bodies: carbon, oxygen, nitrogen, and iron. All of them were forged in the fiery hearts of stars somewhere in the vast universe. Just as the atoms in our bodies were forged in stars that exploded in brilliant supernovas before our sun was even born, there is a deep continuity here, a gentle connection between us and everything else in the cosmos. We are not separate from the universe. We are an intimate, breathing part of it. The same ancient processes that built the giant IC 1101 built us. The same atoms that shine in distant galaxies shine in our very eyes. We are not mere observers of the universe from outside. We are the universe observing itself from within. Third, consider what it means that majestic galaxies like IC 1101 can exist at all. The universe did not have to be this way. If the fundamental constants of physics were slightly different, if gravity were a little stronger, or the nuclear forces a little weaker, stars and galaxies might never have formed in the silent dark. The universe might have simply collapsed back on itself moments after the initial Big Bang, or it might have expanded so incredibly fast that matter never had the gentle opportunity to clump together. Instead, we find ourselves living in a universe where the physical laws allow for the slow, beautiful formation of stars, planets, massive galaxies, life, and conscious mind. IC 1101 is a magnificent testament to what is possible in such a finely tuned universe. It is absolute proof that matter and energy, quietly following simple physical rules over billions of years, can organize itself into structures of staggering complexity and breathtaking beauty. If the universe can slowly, patiently produce a behemoth like IC 1101, what else might it be capable of? What other unbelievable wonders exist out there in the deep dark that we have not yet discovered? This brings me to a vital point about our quest to understand the universe. Every discovery we make, every galaxy we patiently study, every supermassive black hole we observe expands our sense of what is possible. A few centuries ago, people honestly thought Earth was the absolute center of everything. Then we slowly, humbly learned that we orbit the sun. Then we learned that the sun is just one ordinary star among hundreds of billions in our sweeping galaxy. Then we learned that our galaxy is just one of trillions scattered across the endless night. Each step in this intellectual journey has made us physically smaller in some sense, but it has also made the universe grander, more deeply interesting, and far more worthy of our respectful awe. The discovery of IC 1101 is another beautiful step in that journey. It shows us that the universe can build things far larger than we ever possibly imagined. It gently challenges us to keep asking questions, to keep looking further into the dark, to keep pushing the boundaries of what we know. And it quietly reminds us that for all our physical significance on these terrifying cosmic scales, We are the ones doing the asking, doing the looking, and doing the pushing. In the face of IC 1101's sheer enormity, we can choose to feel small, or we can choose to feel wonder. I choose wonder. I want to leave you with a profound image to contemplate as you listen to the silence of the night. Imagine yourself floating in space somewhere near the edge of IC 1101. Around you, in every possible direction, ancient stars stretch out toward infinity. Not hundreds, not thousands, not millions, but trillions of stars. Each one is a burning sun. Each one might have rocky planets or gas giants orbiting in the silent cold. Each one has been shining for billions of years. You cannot even see the true center of the galaxy from here. It is simply too far away, completely hidden behind countless curtains of stars. You cannot clearly see the edge either. The giant galaxy fades gradually, almost imperceptibly, into the darkness of intergalactic space with no clear, defined boundary. You are completely lost in a vast sea of light, adrift in a cosmic structure so unimaginably vast that crossing it would take millions of times longer than human civilization has even existed. And yet, from a small, rocky planet more than 1 billion light-years away, tiny beings who live for less than a cosmic instant have figured out that this wondrous place exists. They have carefully measured its size, counted its stars, and found the invisible, supermassive black hole at its silent heart. They have traced its violent history back billions of years and projected its lonely future trillions of years hence. They have placed it in the context of an entire universe and marveled at its dark grandeur. That is perhaps the most amazing thing of all. Not that a giant like IC 1101 exists, but that we know it does. But before we end our contemplation for tonight, I want to dive even deeper into some of the most fascinating aspects of what we have discussed, because understanding these cosmic giants is not just about memorizing cold numbers and distant facts. It is about understanding the fundamental, beautiful processes that have shaped absolutely everything in our universe, including us. Let us talk more about what quietly happens inside a massive galactic merger, the very process that built IC 1101 and perhaps, in a much accelerated fashion, the ancient anomaly discovered by the James Webb Space Telescope. When I say that a galaxy has consumed dozens of others, it might sound like a simple, straightforward process, like one object swallowing another, but the reality is far more complex and far more deeply beautiful than any simple description can possibly capture. When two galaxies begin to interact in the silent void, the first thing that happens is a delicate gravitational dance. Even when the galaxies are millions of light years apart, they can intimately feel each other's gravity. This invisible force begins to distort their shapes ever so slightly. Stars that were orbiting peacefully for eons begin to feel a gentle pull from an unexpected direction. Massive gas clouds that were drifting along start to move in strange, new ways. As the galaxies get closer, these subtle effects become more pronounced and undeniable. If you could watch a galactic merger in fast forward, compressing millions of years into minutes, you would see the galaxies stretching and warping like taffy being pulled. Long streams of stars get drawn out from each galaxy, forming what astronomers call tidal tails. These tails can extend for hundreds of thousands of light years into space, ghostly ribbons of stars marking the violence of the interaction. During this long, drawn-out process, something truly remarkable happens in the dark. The vast reserves of gas in both merging galaxies get compressed by immense gravitational forces and invisible shock waves. This intense compression triggers massive, sudden bursts of star formation. New stars light up by the absolute billions, burning incredibly hot and bright against the black canvas of space. Astronomers lovingly call these events starbursts, and they can temporarily make a merging galaxy one of the brightest, most spectacular objects in its part of the universe. In some majestic mergers, so much raw gas gets driven toward the exact centers of the interacting galaxies that it falls directly into the supermassive black holes waiting patiently there. This cosmic feeding frenzy causes the black holes to release tremendous, unfathomable amounts of energy, shining as brilliant quasars that can be seen across billions of light years of empty space. The merging galaxies literally blaze with the blinding light of material being consumed by hungry black holes, easily outshining all the stars in both galaxies combined. Eventually, the gravitational chaos settles down into a new, quiet peace. The two warring galaxies become one. The new combined galaxy is significantly larger than either of its predecessors, but it also looks fundamentally different. The elegant spiral arms that might have graced the original galaxies are completely gone, permanently destroyed by the slow, gravitational violence of the merger. What remains is typically an elliptical galaxy, smooth and featureless, with its stars orbiting in a complex tangle of different directions rather than in the orderly disk of a spiral. This is exactly what happened to IC 1101, not just once, but dozens and dozens of times over the slow march of cosmic time. Each individual merger added new stars, added mass, and added fresh material to the central black hole. Each merger gently erased more of whatever original delicate structure the galaxy might have once had. Over billions of years of this relentless process, IC 1101 slowly grew to become the quiet, smooth monster we see today. By understanding this long, slow accumulation, we can better appreciate the stunning paradox of the ancient anomaly, a giant born too soon, challenging us to keep looking into the endless, beautiful dark. Have you ever stopped to wonder how we can possibly know the history of something we can never touch, something that exists billions of light years beyond our physical reach? When we look back at the ancient history of our own small, beautiful planet, we dig deep into the earth, we study the layers of rock and soil, we examine fossilized bones, and we read the geological record as if it were a physical book written slowly over millions of years. But we cannot dig into the fabric of space. We cannot send probes to collect soil samples from the center of a giant galaxy like IC 1101, nor can we physically visit the strange anomalies glowing in the cosmic dawn. All we have is the light, the faint, ancient, stretched light that finally reaches our telescopes after traveling for unimaginable eons. Yet, from these fragile photons, we can deduce an incredible amount about what has happened over billions of years of cosmic evolution. We are like quiet, cosmic detectives sitting in the dark, reading the grand history of the cosmos written entirely in streams of light. It is a profound, meditative exercise in understanding our place in the vast, unfolding mystery. If you find a quiet sense of peace and deep belonging in these contemplative journeys through the cosmic dark, I warmly invite you to join our growing community of gentle stargazers. I am Theodore, the researcher, and I am here to guide you through these peaceful explorations into the great unknown. I have noticed that 71% of the gentle souls who watch these videos and share in this quiet wonder have not yet subscribed to the channel. If these stories bring you comfort, if they help you find a comforting stillness in the vastness, and if they spark your cosmic curiosity, please consider subscribing. It helps us bring more content like this to you. And it lets us know that you want to keep exploring the universe together. Your presence here is deeply valued, and together we can continue to uncover the gentle mysteries hidden in the endless night. Let us return to our quiet observation and look closely at the ancient light that tells the story of the giants. Scientists can actually trace some of the undeniable evidence of these past violent galactic mergers by reading the light of the stars themselves. When brilliant astronomers carefully study the individual stars that make up the vast body of IC 1101, they find distinct populations of stars with very different ages and different chemical compositions. These different stellar populations are remarkably like the geological layers in rock on Earth, with each one quietly recording a different ancient era of the giant galaxy's complex history. Some stars are incredibly old, likely the original members of the proto-galaxy that existed billions upon billions of years ago. Others are comparatively younger, having been formed during the intense starbursts that were violently triggered by ancient mergers. Still others possess completely alien chemical signatures that show they originally formed in different, smaller galaxies entirely, foreign stars that are now permanently absorbed into IC 1101's massive, featureless body. The very core of IC 1101 itself tells a breathtaking story of a violent, tumultuous history written in the dark. The central core is absolutely enormous, stretching nearly 14,000 light-years across the dark void. That means just the central core of IC 1101, not the whole galaxy, but just the innermost region, is bigger than most entire dwarf galaxies. This core alone contains more stars than most complete galaxies in the entire universe. But strangely, it is also unusually faint for its incredible size. Scientists believe this quiet dimness is because the repeated, relentless mergers in the chaotic activity of the central, supermassive black hole have actually scattered billions of stars away from the very center of the galaxy. Here is what physicists believe happened in the deep dark. When two supermassive black holes merge during a galactic collision, they first form a binary system orbiting tightly around each other in the silent void. As they slowly spiral together, shedding energy through invisible gravitational waves, they interact with the countless stars passing nearby, violently flinging many of them outward with tremendous, unimaginable speed. This destructive process, which astronomers call gravitational scouring, can completely empty out the very center of a galaxy, creating a quiet region with significantly fewer stars than you would normally expect. The giant IC 1101 has experienced so many mergers over billions of years that its core has been scoured repeatedly by dancing supermassive black holes. The astonishing result is a massive core that is actually underpopulated compared to what our mathematical models would initially predict. Scientists estimate that hundreds of billions of solar masses worth of stars may have been scattered from the core over the course of IC 1101's long history. That is an enormous, staggering amount of stellar material, far more than the entire mass of many normal galaxies flung outward into the galactic halo, or even ejected entirely into the empty intergalactic void. This kind of painstaking detective work is what makes the science of astronomy so profoundly fascinating. We cannot physically visit IC 1101. We cannot send probes there or take physical samples of its ancient stars. All we have is the fragile light that reaches our telescopes. But from that faint, ancient light, we can deduce an incredible amount about what has happened over billions of years of cosmic evolution. Let me now gently expand our perspective even further into the dark. IC 1101 is the largest galaxy of a certain type that we have found, but the universe is full of extreme, wonderful objects. Understanding exactly where a giant like IC 1101 fits into the cosmic zoo of galaxies helps us deeply appreciate just how remarkable its existence truly is. At one extreme end of the size scale are the dwarf galaxies. These are the absolute smallest galaxies in the universe, containing anywhere from a few million to a few billion stars. Our own beautiful Milky Way has dozens of these tiny dwarf galaxies orbiting quietly around it as loyal satellites. The absolute smallest of these known satellites, a tiny collection of stars like Segway 1, contain only about 1,000 stars in total. They are so incredibly faint that astronomers did not even discover them until highly advanced sensitive surveys began in the 21st century. Yet, these tiny dwarf galaxies play a crucial, foundational role in cosmic evolution. They are the essential building blocks from which the larger, more majestic galaxies are eventually assembled. In the early universe, when the very first galaxies were forming from the primordial gas, most of them were tiny dwarfs. These small, fragile galaxies then merged with each other over billions of years, slowly building up the larger, more complex galaxies we see today. Every single large galaxy in existence, including our own Milky Way and the colossal IC 1101, started as small dwarf galaxies that came together long ago in the cosmic dawn. Moving slowly up in size, we find more substantial galaxies like the Large Magellanic Cloud, which orbits our Milky Way at a distance of about 160,000 light-years. The Large Magellanic Cloud contains about 30 billion stars and has a diameter of about 14,000 light-years. It is actually visible to the naked eye from the southern hemisphere of Earth, appearing as a faint, beautiful cloud like patch in the quiet night sky. The Large Magellanic Cloud is actually being slowly absorbed by the Milky Way right now, as we speak. Gas is currently being stripped away from it, and eventually it will merge completely with our galaxy, adding its 30 billion stars to our sweeping collection. This is galactic cannibalism in action, happening right now in our own cosmic backyard. Then we have the magnificent spiral galaxies, similar to our own Milky Way. Spiral galaxies of this substantial size typically contain between 100 billion and 400 billion stars, and they have diameters ranging from 100,000 to 200,000 light-years. They are quite common in our local universe, appearing as beautiful pinwheels of glowing gas and ancient stars. These are places where the miracle of star formation continues even after billions of years. Our nearest large galactic neighbor, the Andromeda Galaxy, is somewhat larger than the Milky Way. It contains an estimated 1 trillion stars, maybe 2 or 3 times as many as our home galaxy. Andromeda's vast disk stretches about 220,000 light-years across, making it roughly twice the physical diameter of the Milky Way. If you go to a very dark location on a clear autumn night in the northern hemisphere, you can actually see the Andromeda Galaxy with your naked eye. It looks like nothing more than a faint fuzzy patch. But what you are actually seeing is the combined light of 1 trillion stars, making it the most distant object visible without the aid of a telescope. Beyond the grand galaxies like Andromeda, we start to enter the true realm of the giants. Some immense elliptical galaxies residing in the dense centers of galaxy clusters can contain several trillion stars and possess diameters of hundreds of thousands of light-years. These monsters are already among the largest objects in the universe, but they are still not as profoundly extreme as the giant IC 1101. IC 1101 sits quietly at the very top of this entire cosmic hierarchy. Its 4 to 6 million light-year diameter makes it roughly 20 to 30 times larger than the Andromeda Galaxy. Its 100 trillion stars would make it 100 times more populous than Andromeda. There simply are not many galaxies in the entire observable universe that can even begin to compare to its vastness. There is, however, one very specific category of cosmic object that can challenge IC 1101 for the title of the largest galaxy. and that is the strange phenomenon of giant radio galaxies. These are peculiar galaxies with enormous, powerful jets of material shooting out from their central, supermassive black holes at nearly the speed of light. These relativistic jets can extend for millions of light years into the empty intergalactic space, making the total overall structure far larger than any mere collection of stars could ever be. The most extreme example discovered so far is a fascinating galaxy called Alcyoneus, which was announced to the world in early 2022. Alcyoneus has colossal radio lobes extending across an incredible 16 million light-years of space. That is roughly 3 times larger than the physical body of IC 1101, making it the absolute largest known structure created by a single galaxy. But here is the crucial, important distinction. Alcyoneus's enormous size comes exclusively from its jets, not from its stars. The actual physical body of the galaxy, the quiet collection of stars and normal matter, is quite ordinary by cosmic standards. It contains only about 240 billion solar masses worth of stars, which is far less than IC 1101. The jets are truly impressive, but they are essentially just empty space filled with very thin, glowing plasma and invisible magnetic fields. They do not contain the trillions upon trillions of stars that make IC 1101 so unfathomably massive. So, when we speak about the biggest galaxy, we need to be very clear about what we mean. If we mean the largest total structure associated with a galaxy, then Alcyoneus and the other giant radio galaxies take the prize. But if we strictly mean the largest collection of stars, the most massive physical body of a galaxy, then IC 1101 is still the undisputed champion. There is another, deeper way to think about size that is well worth contemplating in the quiet dark. Instead of merely measuring diameter, we could ask which galaxy possesses the most total mass. This turns out to be an incredibly complicated question because most of a galaxy's mass is not actually in the stars at all. It is hidden in something we call dark matter. Dark matter is one of the greatest, most profound mysteries in all of modern physics. We cannot see it with our eyes or our telescopes. It does not emit light, and it does not absorb light. It does not interact with normal matter in any way, except through the invisible pull of gravity. But we absolutely know it exists, because galaxies rotate in ways that would be completely impossible if they only contained the matter we can physically see. Here is the profound problem that baffled scientists. If you add up all the visible stars in a galaxy and calculate how much gravitational pull they should have, you get a certain specific number. Then you measure how fast stars are actually orbiting in the outer parts of the galaxy, which directly tells you how much gravity is actually present. The two numbers do not match. There is far more gravity present than the visible matter can account for. The elegant solution, according to most brilliant astronomers, is that galaxies are completely surrounded by vast, invisible halos of dark matter, a mysterious material that we cannot see, but that makes up most of the galaxy's total mass. In a typical spiral galaxy like our Milky Way, dark matter accounts for about 90% of the total mass. The stars, the glowing gas, and the dark dust that we can actually observe are just a tiny, small fraction of what is really there in the dark. IC 1101 also has a dark matter halo, and it is correspondingly terrifyingly enormous. Scientists carefully estimate that the total mass of IC 1101, including its vast dark matter halo, could be as high as 1,100 trillion solar masses. That is about 100 times more massive than the entire Milky Way. This invisible dark matter halo extends far, far beyond the visible stars of the giant galaxy. While the stellar body of IC 1101 is already 4 to 6 million light-years across, the dark matter halo likely extends even further into the void. Some models suggest it could reach out tens of millions of light years, making the complete invisible structure of IC 1101 and its surroundings truly mind-boggling. Understanding the true nature of dark matter is one of the biggest, most exciting challenges facing physics today. We know it is out there in the quiet night because of its gravitational effects, but we still do not know what it is actually made of. Many scientists believe it consists of some kind of exotic particle that simply does not interact with light or normal matter, a strange particle we have not yet managed to detect directly. Huge, complex experiments are currently underway around the world, trying to catch these elusive dark matter particles as they pass silently through the Earth. So far, none have succeeded. The existence of dark matter shows us that even our understanding of something as large and magnificent as IC 1101 is fundamentally incomplete. We can see the ancient stars, we can measure the stretched light, but 90% of what makes IC 1101 the massive giant it is remains completely invisible to us, detectable only through its quiet gravitational influence. There is still so much we do not know, and that is the absolute beauty of it. The universe is an endless source of wonder, a quiet puzzle that invites us to keep looking, keep asking, and keep finding profound peace in the infinite mysteries of the dark.